All right. Hello and welcome to this number 4 of our SimScale session. My name is Arnaud. I'm application engineer here at SimScale. And with me here is Jesus.
Well, should I introduce myself first?
Introduce yourself.
Okay. So I'm also from the application engineer team. We are colleagues. And my name is Jesus. I'm come from Spain. And to talk a bit about my background, I'm an aerospace engineer. I have some CFD experience and background. And I just joined here the office in Munich from SimScale, and I work especially more focused to customers, so in the post-sales team as a customer success engineer. Mm-hmm. So basically to explain a bit what I do, I basically onboard new customers, deal with them every day with the support they need, and that's basically my daily work. What about you?
So my work consists on something a bit more upstream than Jesus. I work in the pre-sales team, which means that we are trying to see if we can assist any company in the industry with their engineering design challenge and trying to evaluate how much SimScale can bring value to their project. So really, my job consists in demonstrating a potential fit. What we do is we usually try to show what SimScale is capable of in terms of their own industry, and also to work with their own project in terms of their own geometry and their own conditions. So we're trying to really show that with their specific problem, we can assist them. We can provide them with a solution that they can use themselves. They can use the platform themselves, and it will give them a usable result, which means they're going to have a better product that can help in making better design decisions. And this is what SimScale is about, is really providing this added value to the project.
That's
right.
awesome.
I hope that makes sense.
Yeah, but you didn't say where you come from.
Oh, I come from France originally. A bit more detail about my background. I come actually from the other side of what I'm doing now, because I used to work in the industry as a mechanical design engineer, working mostly with pumps, valves, and special purpose machinery over the last 8 to 9 years. So really, I was the person using CFD as a tool and FEA as a tool as well. And because I really enjoyed that part of my job, I decided to fully step in this world of CFD and FEA and trying to solve really interesting and challenging cases.
Yeah,
that's it.
That sounds good. Should we go ahead? I'm going to ask you.
Are you going to ask me questions?
Yeah, I'm going to ask you as well. So what's your favorite thing about SimScale?
So basically, when I joined SimScale a few months ago, there was I was really impressed by first of all the atmosphere here, and also how I was onboarded in terms of how I got into the team. I really enjoyed the how dynamic the team was, and also was really impressed with the amount of expertise, the amount of the standard we were working on, and also yes, really highly knowledgeable people, really nice, helpful colleagues as well. We work in the same office, so we can easily interact with each other. So if someone has an issue, somebody else can jump in and assist, and we're really dynamic in this approach. Also, the location of the office, by the way, is really nice, because we're located in the center of Munich, not so far from where the Oktoberfest takes place. So this is one of the nice little things about SimScale, nice offices. And what I really like as well is that we're all very involved in the product, and we all want to make it better by the week, and trying to really very often brainstorming in terms of what we think can be better in the product. So this is really the main point about this working environment here.
Definitely. Okay, now it's difficult to me to find something else. But
I'm going to return the question, actually. What's your favorite thing about SimScale?
Okay, so I completely agree with you in everything you said. It's true that it's great working here. Like, the atmosphere is awesome. So moving more from the professional point of view that you cover very well, and I think it's quite accurate. I would also like to highlight like the social part of the company, like how often we have these events. Like last week we have this summer party where we all spend a really amazing day at the lake, or every time we do a Mexican party or Indian party, or all these, I don't know, just the moments we spend here in the kitchen all together, cooking, just having lunch. And I think that's great. And I mean, it's a good way. Like you feel like coming to work sometimes.
I mean, sometimes you just come to work, but you just know that you're going to try on new stuff and try on new projects, and it's going to be just really fun. And what I like also about, something to add up on this kind of community we have here is we interact between departments a lot, I think. So the sales department will interact a lot with application engineer and with product development and so on. So this is the kind of interaction that I think is make it really dynamic and really nice to work here.
Yeah, sounds good. Okay, we have another question here. That's a tough one. I'm going to ask you, Arnaud, if you could describe SimScale in one word, what would it be? I already have one.
Oh, you have one?
Yeah, but I'm going to let you answer first.
I think we're trying to, in one word, I would say accessible. So that will be really what the vision of SimScale being an online simulation tool is, that we're trying to have as many people who are interested in CFD and in FEA application to be able to use the tool themselves and in the minimum amount of time for training and getting efficient with the tool. So this is really what the vision is around this cloud-based solution, this all-in-one solution, because we're tackling solid mechanics and fluid dynamics at the same time. So this is really I think the main idea behind it.
Cool. That was a long word.
Sorry, the word is just accessible, I think.
Yeah, I was thinking about innovative. I mean, first time I heard about SimScale, I mean, I have never heard before like about this kind of cloud-based simulation platform where you can have everything on the cloud, everything online. You can open it from any computer, and it's super easy. It works super fine, and also like innovation in terms of like we are always working in bringing new features, in improving what we have, like always looking for more and more. So I think that's one of the things that define SimScale.
Yeah, I mean, it's constantly evolving. So the advantage of it being simulation online based is that we can implement features by the week or on a very on a fairly frequent basis, I would say. So you will see small things changing here and there on the platform, just because we can easily implement these changes.
Yeah, the team is great. Okay, so maybe you can explain a bit how the session is gonna go on, and then we can start. So basically,
So we can start by answering a few questions from social media that we already previously received, and go through all the questions. If you have, feel free to ask your questions on Twitter, on Facebook, and all the social media regarding us as application engineers, what our day-to-day life is at SimScale, or if you have more specific technical questions about your simulation, about the type of analysis we can provide. also feel free to add this.
Yeah.
Mhm.
Yeah. So I'm not sure if you said that, but yeah, I mean, anyone can still ask their questions,
Yep.
and if not, we will answer them afterwards in the
Yep.
forum, in the social media. So
Mhm.
yeah, we can get it started then.
Okay. So we have our first question here. This is from Twitter, and this is Anthony asking us, can you tell me how I can get help for technical questions?
Yeah, that's a really easy one.
That's an easy one. I mean, this is, I think, where we stand strong in terms of what we can offer. So not only we offer this way of simulating your product, but also we're offering you full-time support, which means that at any time when you are stuck on the platform, when you are trying to really understand how to set up a simulation, how to interpret results, you can ask for help through the chat that we have online. So Jesus is more in this part where you're going to assist people in their simulation.
Yeah, I mean, it's true. We split a bit, so maybe sometimes like you are more keeping an eye on these new potential customers that are trying the tool, and I'm more with the people that are already customers that have any kind of problem. So you try to help them every day, but also students, any kind of user using the platform, even though it's a free this community accounts and all that, we help everybody. And it's quite true what you said, that at any time it's nearly it's quite accurate, because actually we have the office here in Munich. We also have the application engineering team as well in the US. So we have a great range of the day covered actually. So yeah, there is always someone there to answer.
Yeah, especially if you had the chance to go onto the chat. I'd like to make a big shout out to Ajit, who is going to be who is our chat guru, and he's always there to answer your question. And I think he's really obsessed with answering people as fast as possible.
Yeah.
And he has like a 5-minute target response, which is really, really impressive.
We believe it's easier to reach out to him through the chat and through WhatsApp sometimes.
He's very, very responsive and very useful. So yeah, don't hesitate to get on the chat, and you'll get through all of us as well. So we all can see if you have any questions, we can all interact with you.
But we encourage all of you to ask for Ajit.
Yeah. Okay.
Okay, should we go to the next one? Okay, this one comes from Facebook, from Abdul Bar. I hope I said it properly. Just want to ask about any SimScale software installation setup with a license for students. So how do we deal with that?
So basically, there's different types of license. But first of all, I'm just want to make sure that the idea of SimScale is that you don't need an installation, and SimScale by itself isn't really considered a software, but more an online platform. So you won't get an installation file. You won't need to upgrade your software on a regular basis. All you have to do is get on the website and start uploading your geometry and start simulating. So this is the first part of the question. There is no installation required at all. The second part of the question is, do we have licenses for students? And what are the types of license? So we have our community type of license.
Yeah.
In which you can, for free, upload your model and start simulating. You have access to the FEA modules. You have access to the CFD modules in compressible, convective heat transfer, which involves the temperature, and so on. And then you have professional license for companies mostly, and you have student license, which in which you, as a part of one of the educational program, I would say, you have access to more computation capability.
Yeah.
And this is what we call the concept of core hours. So there's a computational quantity that you can request if you work in the educational environment. So we have, for example, I think a thesis student who worked with us as well.
Former students, teams, all these kind of students that want to get the advantage from the simulation. We can have this kind of relationship, sponsorship, agreement, however you call it. And we have this SimScale Academy, I think it's called. You can look for it in the web. And it's really helpful when you are not still like a big company or whatever,
you still want to,
and you still want to have access to simulation. It's pretty good.
Exactly.
Okay.
Next one.
This comes as well from Facebook. Yeah.
Okay. Matt is asking, I'm curious if a new version of SimScale is going to be released soon. How often do you release the software? Yearly, quarterly?
Yeah. I mean, it's like talking about versions. Maybe, I mean, you should ask the people from the back end, front end, wherever, like they are more used to it. But I would think of versions more like with this kind of softwares that it's like a fixed package, and you have to release new things. But I mean, in reality, what we have, it's like they are implementing things every day, maybe like really tiny things that you don't even realize as an user, but we are all the time like trying to fix some problems or try to make more efficient some tools. And I mean, from time to time, like every quarter, I would say we always release like
a big one,
like a couple of big ones. Well, the last one was, for example, automatic contacts for conjugate heat transfer with the new measure that helps a lot, like makes the setup to go from several minutes to just in the moment.
I mean, this is really good because you can also suggest, I would encourage you to suggest some improvement that you would like to see on the platform through the chat, for example. And I have a small story actually where there was something that I couldn't quite find why it was made like this. It was about the tabs, when you're on your browser and the tabs, the workbench, it was just shown workbench. And this was amazing. I was super impressed by the fact that I raised this issue, but there's always workbench. You don't know the name of your project in the tabs. And I raised this, and maybe like a week after, it was there. It was changed. And this is how quickly we can make things changing. And now the name of your tab is the name of the project you're working on.
That's really useful.
And this is how it's very useful. But I was super impressed by the fact that how fast this change was implemented. It doesn't take like months of approvals and things like this. You just have it right away.
Yeah, I can remember that day you were quite excited.
Yeah.
Actually, that happens to me as well this morning. I was having a call with a customer and I just realized about a new feature. Before, when you are setting up your case and you run the mesh, you cannot start a simulation till you have a mesh. That's logical.
Yeah.
But right now, you can already run the simulation and it will be there waiting. And once the mesh is finished, it will automatically start the run. So you don't need to be waiting for the mesh to be over and then you manually click on run. So, I mean, and I just realized with the customer, I was like, no, it's not going to work because you need to wait for this, and suddenly it was like loading and I was like, wow, it's true. This is new.
I mean, this is one thing actually I like about SimScale is every couple of weeks we have the new features meeting where we have like all these little things coming up, and every time I get super excited because there's like oh wow, we can do that now, and effect. And maybe I'm one of the very excited person.
It's true. We are easy to get excited.
Because we see what the product development team does, and that's a good thing that they can like feed us back on what they've been doing the last few weeks. So it's really good.
Okay, let's move to the next one.
What do we have? We have Mr. Reveal01, and regarding the webinar tutorial simulation videos on YouTube. This is a question we have from YouTube. Can I get the simulation file, and is it in the community? So the answer is yes. For every webinar, every tutorial we make, there's in the description the project in which you can have access as a public project, and you can also, of course, download the simulation file. So this is for every simulation video we make. There's a public project attached to it.
Yeah, and you can always, you can have it online, and you can also download the CAD, you can download the solution, you can download the mesh. So just in case you have another software in your computer where you want to check whatever, like you can do all this stuff. Yeah.
Okay, another question.
Okay, here we come with live questions. What is the significance of cell Reynolds number in a simulation? Is the model used to affect the cell Reynolds number?
I'm not quite sure. Do you know what that mean? What it could mean by cell Reynolds number?
I mean, I know what the Reynolds number is, definitely, but not that sure about what he's referring to this cell Reynolds number. Okay, we are receiving more information here. Yeah, I mean, we can always like share, like there are links to documentations and all that, but basically the Reynolds number, what means it's saying it's a non-dimensional number that quantifies if your flow is laminar or turbulent or how turbulent it is. So it depends on the conditions of the flow, on the viscosity, density, the conditions of the geometry, a reference length, and the velocity of the flow. So with all these kind of variables, you can know how turbulent it is, and then the solver will act in one way or the other to try to solve this kind of large eddies and small scale eddies. I guess it's something about that, but yeah, I mean, if you still feel like the question is not properly answered, you can later ask there in the forum or in YouTube.
Okay. So yes, I mean, this is an interesting one because it's really the base of what CFD is based on. In most cases, we use what we call the average Reynolds average Navier-Stokes equations that the simulation solves, and this uses a few equations and trying to solve them over the flow. And the Reynolds number gives us an indication of, as you said, the kind of regime we're operating with, and this is the fundamental of CFD. It's really it determines the kind of approach we are going to have with regard to a very specific project.
Yeah. So yeah, we actually, that was quite fast. We have a reply from the previous question, and he says, when we mesh the model and later post-process the simulation, does the Reynolds number of the mesh cell represent turbulence? I mean, it's not like it represents turbulence. Like you can represent turbulence with vorticity, with all these kind of variables. Basically, what the Reynolds number tells you, it's what kind of flow you are having. And basically, for example, if you want to compare, talking about aerodynamics, so if you want to compare the same flow conditions from one model to the other, it's really important to have like the same Reynolds number to have the same flow patterns. So the Reynolds number, it's going to affect in this turbulence and in these flow patterns that you're going to see in the wake and all that. But it's not like the Reynolds number tells you turbulence directly. I don't know. I mean, it's getting a bit technical, but that's how it works, more or less, I would say.
I think you might also refer to what we call the Y plus value, which is directly like a more of a local type of Reynolds number. And this is something that needs to be checked when you run a turbulent flow analysis. So basically, as I said, the Y plus value is a local value of Reynolds number. It's basically the ratio between the momentum forces at this specific location
Mhm.
to the viscous forces. So when you are at the mesh cell, depending on how big your your cell is with respect to like a fixed wall,
Yeah.
then you're going to see in what regime you are at this specific height from the flow.
Yeah.
And this is something that needs to be captured. This element of at the wall you have no velocity, there's no fluid flowing. But as you progress throughout the inside of the cavity, then you start to see a fully developed flow.
Exactly.
And this is with this transition from zero velocity to a certain velocity that the Y plus comes into account.
And that's what really affects the model, because if you are using a wall function, you need a bigger Y plus range. It will be around from 50 to 200 or so Y plus. Then if you want to have a full resolution of the wall, near the wall, and not add this modeling, you want a Y plus around 1 for runs models. But then if you are going with LES models or other kind of turbulence models, you want a specific Y plus to be able to capture these little features, these little eddies in the flow. So yeah, that's basically how it works.
Okay, still talking about meshes.
Yeah, we have a new question here.
So there's a question from Valdi, who is asking, what is the new mesh preview? So a few months ago, we started to implement a new mesh algorithm, and this is something that we call a new mesh preview. And it's a mesh algorithm that is being developed by a third-party company, and that provides meshing solutions. And we've adopted this kind of, we're trying to really implement this more and more into more of a project, and trying to really promote this way of meshing, because it turned out to be like a really high efficiency and high performance type of mesher. And it meshed roughly twice as fast as the usual one you would have as a X dominant kind of mesh. And this is something that I would encourage you to try and see if you get similar result, or if you want to play with it a little bit. And that's something we try to really use as much as possible, because we really believe in this kind of measurement.
That's something that we already did, like testing this and checking with the tetrahedral, for example, especially when we are talking about finite element analysis. We tested with the other measure we have, and in most of the cases it was way faster to generate the mesh. And also for the solutions is way better, because it's crazy how good it is at capturing small features. So it's really automatic, and it really detects where you have a hole, where you have these important features in the geometry, and it can go really fine there to better capture it. But then it gets like bigger cells in the rest of the domains where it's not that important. And there are a lot of projects actually that before we were struggling to get a good solution, and since we got this new mesh preview, we were able to have like really good results and really fast ones as well.
Okay. So we have another question from Victoria, and Victoria is asking, can you explain the radiation feature? I can get that one. So this is something that we've developed and implemented also a few weeks ago. It went live, and this is something that was highly requested by our customers, and also on the chat. And it was something that was highly demanding in terms of HVAC application, where we are just simulating an indoor environment where we have windows emitting radiation, or standard heating element like radiators. So the radiation feature really simulate this heat transfer phenomenon, because we have to know that we have conjugate heat transfer phenomenon, convective heat transfer, and the third one would be radiation heat transfer. So we were trying to simulate this third one and implementing it. So it's really having the simulate the effect of radiation on surfaces. So on a normal environment, you have surfaces emitting radiation and some surfaces collecting and diffusing radiation. So from with this new feature, you can now simulate this effect of surfaces absorbing radiation and some surfaces emitting radiation in a diffuse way. So you can easily simulate the effect of the sun acting on a window in a diffuse way throughout this window. This is one of the what we call boundary condition that defines this specific behavior at this window.
Yeah. And actually, we recently have a webinar where we were discussing about this new feature about radiation. I would really encourage to look for it in YouTube. It should be there. I don't know how it will be called, but if you look for SimScale webinars,
HVAC with radiation, I think it's called.
Yeah. So there you can check how it was set up. You can check the results comparing with and without radiation, how it worked, and you can always go to the platform and go to the project and check it there as well.
Yeah, absolutely. Yes. What do you want to say?
What? Yeah, we can change to German at any time.
Yes. No, we
can't.
I don't think we're very proficient in German at this stage.
Yeah, we still need more time here.
I mean, the entire company language is English.
Yeah.
So it's very convenient to communicate, and we have a wide range of country represented here actually.
Yeah.
So let's actually make it a very nice multicultural environment, which I like.
Yeah, that's something we missed at the beginning, but yeah, it's another great thing about SimScale.
Absolutely.
Okay, we can go to the next one. So Sahil Kukian is asking, what kind of hardware are you running on your servers, and what made you choose it? This, I would say, it's a bit far from the application engineer part. But yeah, I mean, we are using, it's not our servers. It's a third party as well that offers all this computational power. So basically, I can't give you like the exact data of what kind of machines there are in the servers. I don't know, but what I know is that they give us up to 96 cores for every kind of simulation, and that you don't have any queue when you are running a job. So, I mean, I was used when you are in the university and you have this kind of servers and you are running things in the server. You have some kind of priority, and you have to wait maybe one day for this job to enter the server. Here, it's not like that. Like it's automatically enters the server. There is no priority, so you can run 10 jobs at the same time, and then they all will enter at the same time in these servers. All the technical information I can give you is that we have 96 cores for simulation, and we have also the GPUs, the graphic cards. That make our solver. We use it for the solver for pedestrian wind comfort and wind loading, the LBM solver, and that makes this solver like really, really, really fast. Like we can run like huge models. Like it's crazy how you can put there like a huge city with a lot of buildings and say like, okay, run.
And you have 20 million elements and they solve like this in a transient way. That's very, very impressive.
GPUs are really like make the difference here. So that's basically what the servers offer to us.
Okay. I mean, this is really the advantage, like having high computational power on the cloud, just like this. And runs all these things at the same time. It's amazing.
Yeah, that's the good thing. In your local machine, there is no way you can do that.
Yeah. This is nice when, for example, you want to compare different geometries. So coming from my specific background in pump design or valve design, where we don't know exactly what the hydraulic shape would be, then I try to upload different scenarios where we have different opening size, different vein diameters and things like this. And I can run all these cases all at once, and I can visualize the result at the same time, at the same moment. And this is something that's really nice.
Okay, I can see we have another question here live. So Anatol is asking, which upcoming feature are you most excited about, if you're allowed to talk about it? Now I'm afraid to talk. I don't know if our boss is there.
I don't know
maybe
if
there will be any problems.
Yeah. I don't know if we should give spoilers or something. I don't know.
Yeah, I guess what I would say right now, what we are more like excited about, I'm working really hard on.
I'm excited about something, but maybe you have some.
Should I or should you say it?
I don't know. I mean, for me, from my own perspective, what I really like is that we're really trying to implement, to make the process of importing your CAD model into SimScale very, very smooth, in order that you can get onto your simulation very quickly. So we're implementing a lot of different tools in order to prepare your geometry into that, to make it simulation ready. So it's really like building all these really useful, intuitive features, like extracting the flow out of your geometry, or making it more refined, or really, or on the other side, deleted some element, and you can you will be able to do that on the platform. And this is something that I think is really, really useful and very, very impressive in the way that we are progressing through it. We're progressing very fast, and it's something that I really like.
Yeah, I mean, I would say like the crazy future that they are working, I know they are working a lot in the simulation team right now. It's about the Lawson plots for the LBN solver. So you can Google it and see how they look like. But this is like a really awesome thing. Like they are playing with like geolocations and to know exactly what, like the wind direction and velocities and at each direction, so you can easily like choose where is your building place or something like that, and have like real data and everything like really automated in the platform, and really like to make it an application, to make it super easy to just upload the model, say where is your model place, and just run it with different directions or the real conditions. And that's gonna be crazy.
Yeah, I think again is to make it very, very accessible. So really trying to have the least amount of step in your simulation, in order that you get result as soon as possible and you are successful very quickly as well.
Okay, we have more questions here. This one comes from Doan Nguyen. Can you help me make a simulation about rejecting heat from outdoor unit at riser for high level building? Yeah, why not? I guess, I mean, I'm not sure. High rise building. Okay. Yeah, I mean, you can do both, either if it's natural ventilation or mechanical ventilation. That's something that actually I work on. we had a webinar about natural ventilation not long ago. In this case, it was like a house with a chimney where you can see how the air was going in through the first floor to the getting out in the second floor, like going through the chimney, getting out of the house. So you can definitely do all this kind of ventilation simulations, just taking into account the flow, or if you also want to take into account the temperature, if you want to take into account the change in density, if you want to make it incompressible, compressible, like there are a lot of possibilities. So he says that I have tried many times, but didn't still take good results. So yeah, that's why we have the chat. That's why we have the live chat. So you can always say, hey, I am the guy from the Ask SimScale the other day. Here you have my model. So you can ask for us or for Ajit. That he's great. And then we can help you to make your simulation successful.
So if you allow us, you can share your project with us, and this makes it so that we can access this specific project and we can review what your setup is, what your results are. We can directly check what you've been doing. So this is also a huge advantage of being completely online, is that we can really send each other the link to the project, and it can directly target and advise you from what we see online.
That's great. Okay, we have another question here. Konstantinos Misios. Hi guys, regarding the software that you use, is it entirely developed in-house or is it based on other codes? Should I?
Yeah, sure.
Okay. Well, we have different in-house, in-house and open source codes that our software is based on. So we have both FEA and CFD. So basically, CFD is based on OpenFOAM. FEA, it's based in Codaster. But as we said before, for example, with this new measure, like we started from there, but then we have been implementing new stuff since the beginning. So, for example, radiation, the new measure, automatic contacts. So it's like that was the beginning. That's the base of all the software. But then you can do things that you won't be able to do it in OpenFOAM, plus having all the interface, having the post-processor, for example. We are also working in a post-processor right now that should be on the platform soon. So that's the thing, like, yeah, the main, like the origin was OpenFOAM and Codaster. It's the basics, but then it has like a lot of new features that make it unique, actually. Yeah.
Exactly. For example, LBM, this part is also based on another code that's being developed for us.
Yeah.
And this is really targeted to the WinComfort applications, for example.
That's the one that it's like really in-house, that we have it here, and it's and we also have like the opportunity. That's why we have the opportunity to implement so many things and grow that much in that solver, as it comes directly like from in-house. So yeah, that's basically the three main solvers we have.
Yeah. Okay, next question from Siddesh Pujari. Please tell something on writing algorithm for CFD. What are the requirements to develop code? I think this could be a good question for our simulation team, who really digs into the code and try to implement new libraries and try to optimize the code. But this is something that has to do more with OpenFOAM, as you mentioned.
Yeah.
But we can definitely.
Yeah, actually, if you are an OpenFOAM user, you have like this taste of the CFD code, because you can access it, you can modify boundary conditions, you have the access to the code. So this way you can have some tips on how you should write an algorithm for CFD. But what I was thinking about, it's like people is really wants the simulation team to come to an Ask SimScale session. I think it's a good idea.
It's going to be the next. I think it would be nice if you could leave in the comments who should be in the next Ask SimScale, because you've already seen a few of our colleagues, so Sam and Matt, John,
and most of them were application engineers. So we are like the link between the product and the customer.
Yeah.
But we have like a great sales team that it goes crazy finding new opportunities. We have people getting more involved with the platform, how the platform should look like, how intuitive it is with the post-processor, people programming these new features in the solver. So yeah, I mean, we have a lot of teams that could be also interesting to make them join these sessions.
Okay, well, that's very good. Okay, so I think we are about to reach the end of this session. We are going to answer any other questions that we couldn't answer at this time, and also a bit more develop on the other ones, especially the cell Reynolds number question, maybe.
Yeah.
And that's all we have for you today. I don't know if you have something else.
No, I think it's been a really nice session. So yeah, I mean, anyway, we are, as we said, we are online always. So you can always ask your questions in the forum, in our social media, in the live chat. So yeah, from my side, that's all for today.
All right, and yeah, we'll catch you in the next video. Yeah. And until then,
yeah,
bye.
Yeah, bye.